Okay, so we're going to try to use a limit comparison test to show that this thing converges. So essentially on a limit comparison test, what I do is I look at the numerator and I find the most powerful thing that I have up there. In this case, I just have a 1, so not really anything to worry about. And then the denominator, I find the most powerful thing that's there. So obviously n squared is bigger than 4n, which is bigger than 5n, excuse me, just 5. So I'm going to get rid of those guys there just for the time being. And then I'm going to say, oh, well, I know 1 over 3n squared is a convergent p-series with p is equal to 2, which is greater than 1. So I will just clean that up right there. Okay, so the next thing I want to do is find the quotient of those two, and if it is not 0 or infinity, I'm in good shape. The quotient of the limit. So I should have written n equals 1 to infinity. So I'm going to do the limit as n goes to infinity of the quotient of this series that I know converges, or diverges, doesn't really matter. In this case, I'm using a convergence series. I want to find the quotient of these two series. It doesn't matter which one I put in the top or the bottom. So I'm going to put 1 over 3n squared on top, and then 1 over 3n squared minus 4n plus 5 in the denominator. So hopefully everybody's okay that I'm going to flip and multiply these things. I don't feel like writing out that I actually did that, but I do want to rewrite it as one fraction, not a complex fraction. So now in order to find this limit, I can do L'Hopital's rule, which is kind of annoying because I'd have to do it twice. Or I could just multiply top and bottom by 1 over n squared. So I get the limit as n goes to infinity of 3 minus 4 over n plus 5 over n squared over 3. These all go to 0, and this is just 1. So notice that I got 1, which is not 0 or infinity. If I got 0 or infinity, I picked the wrong series to worry about. Okay, so this way I have written down convergent p-series, and then I write limit comparison test converges. It's all set. So notice that I put the series that I knew converged, or in later cases diverges, I put it in the numerator. It doesn't matter. The bottom line is that I'm picking two series that are going to behave pretty much the same. And how do I know that they behave the same? Because when I find the quotient of their limits, I get a finite number. If I picked something that was not very similar to this one here, meaning if I pick like n cubed or something like that, I probably would have gotten a 0 over here, or an infinity. And if that was the case, I picked the wrong series. So you want to pick something that you know behaves very similar to the one that you're trying to determine whether it converges or not. In this case, I picked 3n squared. It gave me a nice number, meaning not 0 or infinity. So therefore, I can say limit comparison test converges. And then I have written up here, p series converges by p is equal to 2. That's a sad looking equals.